Hey, so I was watching The Big Think yesterday, and I'll put a reference to that episode in the chat because there was a physicist on who talked about um, entropy and the whole thing about time going forward. So the twin paradox, and I didn't see the whole 1 hour episode. I just saw the the um, the 10-minute version that Big Think publishes. So I and Yes, I could watch the whole thing, but I can't deal with an hour of physics. But I can deal with what he said. I can deal with the philosophy of it. So let's do that. Um, his the final point in the what was in the edition was that the future is one of increasing entropy. So entropy rather. So and it's he explained space time where there's space and time is one thing, but it's space time. He didn't go into electromagnetism, um, but which has quantum theory. There are no quanta in space time, as far as we know, because has to do with motion. However, um, just I'm positing that with all of the and this is where actually they link for in the universe, and this is probably the in the universe of space time, the total sum of possibilities equals one. And in fact, that's just a way of that's when space time acts. It's actually the same as electromagnetic theory, the electromagnetic indeterminacy. That there's only one. There's the future electromagnetic states in the universe equal one. So space time is what the measure is the markers of that is the reference point for the electromagnetic indeterminacy. Here's the thing. Indeterminacy means you've got an infinite number of options until the waveform collapses. Once the waveform collapses, there's only one waveform. It's known, and no other collapses are possible at all. So there's no multiverse of the past. There's only one universe that's actually occurred in this universe. There's only one path that has happened. It's indeterminate, or it's determined in the past. It's indeterminate of the future. If it's not indeterminate of the future, then the entire theory of quantum indeterminacy collapses because there's only one path. And you can't have a multiverse for every that's determined and have indeterminacy. They don't live in the same universe. In fact, there's if you were to go into another universe, assuming there was a multiverse, in the future of that multiverse, when you enter it, is indeterminate. It has to be, both in terms of space, time, and the fields. And electromagnetism. But it's set in the past, and your entry at whatever point you enter, the wave function has already collapsed. You can't once you get into a universe, its past has already collapsed, and its future, may be, by definition, is indeterminate. So, it starts from wherever you enter that universe, or whatever the story enters. It's a verse. Verse means story. So, yeah, you can't have indeterminacy and have the future be determined. It's like that's, and it would take an infinite amount of energy in every universe to realize every possibility. But as soon as you get to that point, it's determined. It's collapsed. It's pre-collapse. So in the future. So yes, the past is totally indeterminate. All possibilities are possible at some level. They're not likely, but they're possible. And some things are very unlikely, very rare. And maybe we can look at the most likely patterns. I saw also last night a video where Google Maps has their way of predicting what the best track is. Just because you know the best track doesn't mean you're going to take it. Sometimes people take detours. But until you take the detour, it's indeterminate. So yeah, those people who believe in quantum theory cannot believe in future determinacy. Past determinacy, yeah, it's collapsed. But as long as there's a future indeterminate, there's no multiverse. There's a multiverse of possibilities, but there's no determinacy. You can't have determinacy and indeterminacy exist on the same side of the collapse. Now, in the future, it will have collapsed, but the past will have collapsed. But that's in the future. We're not there yet. You can't. And there's only one path. It's determined after you get there. But at any point in time, the future's everything is possible. So it's not that everything is possible, and there's a universe of everything being possible. There's one universe where the universe is collapsed and you're in it. And once in the future, when you get to that future, it's collapsed. So yeah, the past is uncollapsed. There's only one path where the waveform is already collapsed in the past. You can't enter, and if you enter a timeline, it has opened up the probabilities in the future because you've altered them, but it's collapsed before. So effectively, there's for you, there's only one universe: a collapsed one, which is the past, and an uncollapsed one, which is the future. So yeah, that's the whole thing of a multiverse. It's not really existing. To say the future is determined is to say that in every universe, including your own, there's no indeterminacy at any point. And that's absurd. It doesn't exist. There are free variables. We can model the future with fractals, but it's indeterminate wherever until you map the fractals or put forward the fractals. Where the fractals go is indeterminate until you map them, which is another form of determinacy. Which is an estimate, but it's not. That just shows likeliness. It doesn't show collapse. So collapse is always the current timeline. It's and it collapses every moment. Is the collapse coming? It hasn't come yet. It's just now. Oh, it's over there. It's collapsed. Same thing. That hasn't. What Augustine said about there only being one future. It's not true. The future is uncollapsed. That's why we have free will. As long as the waves have infinite probability in the future. Both the position of space and time that you occupy. Now there's likely versions. There's very likely versions of space and time, but they can be changed with the application of the electromagnetic field. motion and motion. Um, Time marches on. You know, that's what collapses the waveform. And your present position does lead to your immediate future waveform. In matter, you can't go to every single possible space. Only the one next to you. You know, there's a limited number of possibilities. You can't like go from Earth to Alpha to Proxima in a second. There's a path there, you know. It's all probable paths, you know, in the near future are pretty much determined, but not in the far future. We have no idea what, you know, 10 years from now, if there's a it will be there or not. If we do some kind of anti-gravitational proportion where we can arrive at grav weight, if there's such a thing, then or if there's no thing that we can generate, you know, motion, we can generate motion. But if we can generate motion at 1g, you know, using what Heinlein called the broken washing machine propulsion, that's where you have an unbalanced system, and the direction of the imbalance causes acceleration. You know, in other words, you know how a washing machine moves when it's unbalanced. You can do that with magnets and weights and especially counter-rotating weights, so it's stable. It's relatively stable. It's controllable. I won't say it's stable because stable means it's already happened. So that, you know, one spins one way, one spins the other. You know, there's more force going up than there is weight holding it down, or mass holding it. If your motion exceeds your mass or your mass in motion exceeds the mass that is fixed, then you go up. You know, probably with the maximum being 45 degrees from your axis of rotation. That's what me and my friends in Planet in 1000 Planets speculated on. But it's a 45-degree angle. Because once you get to 90, then there's no up and down motion. You know, if you're beyond 90, it's a down motion. If you're under 90, though, it's up. You can try that by spinning with your arms out and seeing what it feels like down and up. Obviously, it's, you know, the reason is if it's going up, then, you know, then there's you're lighter. If you go down, you're heavier. If you're like going this way, then it changes your apparent mass, your relativistic mass. Your mass is the same, but the motion of the mass has changed. So yeah, so if we spin to the extent that we get 1g acceleration, or maybe 2g. You know, if you have a hardy crew, or 1/3 g if you're going to Mars. What you don't want, and you want to acclimatize yourself to Mars, and then on the way back you go 1g back, so you can go faster back. Or there's a curve where you can go from 0.4. 0.3, whichever is best. I think it's 0.38 anyway. You start at whatever you're at, and then you get to 1 when you're there. And you start at 1, and you do with the other. And you'd have to have some kind of curve so your body isn't shocked. So, yeah, which is, if you want to do the calculus on going to Mars, then you'd accelerate it. You'd start at 1g and you'd end at 0.3g, but you want to be at 0g for the flip. Actually, that's not true. You can go up to point to 0.99c when you get till you flip, and then you start your deceleration at 0.99c, and then or the at the same acceleration. Actually, you'd have to figure out how to not suddenly. Well, no, you can still go from one acceleration to zero. We do it all the time. And then you flip, and then you decelerate, starting at at 1g, but you finish your deceleration at 0.3, so that you're acclimatized. So, and you can figure that curve out. There's one possible curve that's optimal, using calculus. If you from any point that you and Mars are where Earth and Mars are, there's a solution that you accelerate at 1g until a point where you have to then decelerate, with the end being at the effective acceleration of the planet you're going to, assuming you're landing. You don't have to make that assumption. You can go at 1g, as long as your floor plan goes with it. But then you have to shift your floor if you're going to be a space station. And then if it exists, go by the get your gravity from rotation, assuming that that's even possible with the inner ear. We don't know that that's possible. We haven't tested it with humans in orbit yet. In fact, I don't think we should even worry about going to Mars until we've actually tested it, because it's indeterminate until we test it. Could work, it could not work. So we know the wave function has not collapsed yet. So let's collapse that particular wave function and actually, put something in the sky that says if we can do it or not. And if we can do it, then just like with the gravity propulsion, if we can do that, then you'd have to have some fancy thing where if you're going to travel if you want to travel to Mars, and use the acceleration as your gravity, you eventually have to get to the point where your acceleration is no longer your gravity, and that the motion of the habitats has to be perpendicular to the axis of rotation. And the spin be at the rate where you're forced down, and then you have to learn how to pour a glass of tea where it comes out of the spout, and then you have to go by the acceleration. So there's a curve into your cup, and you have to make that intuitive, assuming that's possible. We don't know yet. If it's not possible, we can't go, because Mars is not survivable as it is. What's possible is to put a space station in orbit around Mars, where you rotate at 1g, so then you can have like normal aging, kids be born normally, plants happen normally, because we are tied to our gravity. We can devolve into a 0.3g species, but that 0.g species couldn't come home, or if it can come home, it would have to be conditioned in transit, if that's even possible. they may have to live in 0.3 g stations around the Earth, where there's a 0.3 g rotation and never actually go down, or you maybe start at a 0.3 g station and then increase your rotational speed until you get to the point where everybody's acclimated to a 1 g rotation, and then in terms of physical growth or physical stamina, which may be possible, may not be. You'd have to try it. And whether the pregnancy is possible or not. I mean, in a pregnancy, you're floating, so there is no weight, just mass. So at some point there has to be a position and mass, but early in the pregnancy probably not, of any species, particularly humans. So, but yeah, that's but point being that we could accelerate to if you're accelerating toward Epsilon Eridani, aka Vulcan, that's the star that is associated with the planet Vulcan, in canon. Then it's a star empire in the tech manual, which is amusing. So, going there, if you can accelerate to 0.99 c, you can get there in a decent amount of time. 6 or 7 years, I think it is. It'd be the matter of how long you would accelerate to 0.99 g. I don't know. I haven't done the math, but it's doable. I just don't have the tools to do it. But somebody does it. That future exists, but not in mine. I'm unwilling to expend the mass, the electromagnetic force to go to that level, or follow that path. I can ask the question, and somebody else can do the damn physics. But I know the physics is possible, and I can say, please do the physics. So you can, you can navigate that journey. If you can assume 1g acceleration, and then a certain and deceleration, unless you want to make it just a loop, just to say you've been there, but you wouldn't have any time to make your measurements. When you get there, when you're at 0.99, time does not your relative time is different. By the time, if your entire trip is 0.99, oh, there it was. For the entire period of acceleration, you wouldn't see anything. You might have snapshots, but they'd be slow-mo, actually, or fast-mo. So yeah, you can't. Your camera could not be the same thing. Now, if you install cameras and have very fast data speeds, you could send cameras in the future, and then just have your humans go around and grab transfers of all of that, but to make your map, or you just have them do a round trip with deceleration. So yeah, it's nothing like being there. So you have to accelerate and decelerate around to Proxima, and that's a known curve, or a knowable curve, I should say. There's a knowable path for a best path with given certain accelerations that are consonant with human geography, and then a spaceship that can go from everything being down to everything being like that, 90 degrees of free motion for your range of motion for your craft, and maybe even yeah, if you can if you have a really versatile craft, you can make it 90 degrees of yeah, it would be 45 degrees of no, it would have to be 90. It would have to be 180 if you want to decelerate be able to decelerate um, in both directions. I'm not sure how you would do that. Um, I mean, you'd change your barriers. So you'd actually have to move whatever you use to to block your block the block the rotating mass from getting to where it wants to go energetically. So if you want to use hinges on you'd have to have hinges on your drivers on your shaft of rotation. Um, the question is, how do you fit everything together? I guess you can have inflatable portions of your thing, but that's problematic from a structural point of view if you're going that fast. Um, and you'd have to have something that your mass is infinite, but the mass of anything you strike is not. If you're near the speed of light, your mass is infinite, and the mass of any particle going to you is infinite. But if you have so much mass and that has less mass, it's not going to be noticeable. You can't. If you can strike the odd rock, and your mass will overwhelm that rock, especially if that rock is stationary and you are not. You have infinite mass, or near infinite mass, and if you've got near infinite mass, your reaction to little pebbles is going to be different than if you're the one staying still and it ain't moving. But we can get, there may be some energetic happenings, but your mass being near infinite would not feel the effects. I'm positing. I don't know. You have to send some system up and then shoot it. I don't think we have enough ability to model that. But yeah. So that's space exploration. And again, there's infinite possibility in doing that. But it's the degrees of freedom you have in that uncollapsed field is somewhat determined by current position. Where you can move to is indeterminate, especially in the long term. But what's likely and unlikely doesn't. The unlikely solution is still unlikely. It could the waveform could collapse in a certain direction. But it's a 90-degree cone. So yeah. So hopefully they'll build a system where we can have both that we can test both artificial gravity and test whether you can do acceleration by using the broken washing machine method by rotation. So yeah, so it's the same problem. If you're rotating out, is it survivable on the circular? And if it's and does it generate motion if it's at a 45-degree angle? So, and then where's the point of what's the gravity at the at whatever is perpendicular to the shaft. Is that one gravity? And you couldn't go between modules. So, and I don't think I think it would probably be spinning faster than 1g when you're trying to do 1g acceleration. So you'd have to have it be flat. You'd have to go full 90. So there'd have to be arms going out, and then your hinges would be on the arms. And then there'd have to be some kind of full collapsible distance, or some kind of collapsible feature that connects them together. This is assuming that, what spins has to be the manned piece. So maybe there's two sets of modules. Thinking aloud here, because if you're living in you can't live in what's spinning, but you have to spin where you live when you get there. How diabolical is that? So you'd have to have separate configurations of things that move. But both of them would have to be stable when you're someplace. So you'd have to be the rotating mass would be at 45 degrees, and you'd be at the people would be at straight up, and then when you get there, you then have to make it the one wouldn't move, or it would move up, but it would move. One rotation wouldn't move up at all, but one would move to generate 1g. So there's two kinds of movement to your modules, and you can probably stack your modules though. You can have, like, on the walls of the ship, multiple modules that are then reorganized into one ring. So you'd have a multi-story thing. That's doable. So that's how you would do it. You'd have multiple levels of crew, but your apertures being spinning. Weighted apertures, but they have to be very heavy then, because they'd have to make the mass of rotating matter has to be greater than the mass of what doesn't rotate, which is huge. If you have any kind of ring system or any, so but you can go pretty, that the function that determines how fast you go isn't it's still a 45-degree angle, but it's the how much spin you can put on it, how much weight you can put on it, based on the speed of the shaft. So what's required is how fast you can make the mass spin, which is your reactor is a determinant of that. However you want to do that, and the physical, and the matter qualities that you use to do that. Because eventually your habitat, unless you can stay, if you can stay, there's no problem with moving around the habitats until you disembark, unless you just want to have your habitat be a tower, but then you don't have to fully staff for the for the rotational modules. What I'm saying, right? That, you know, if you want a linked ring that travels at 1G, there's a certain amount of modules you link to your hull as it's moving at 1G, but then the weight of mass that's rotating that drives of your propulsion system has to be able to get to the speed to get to 1G and carry the weight of the modules as well as the reactor and course and hull and systems. So you want to put as much as you can into what spins, if you can physically do it. Storage, I don't know. There's a whole bunch of your equipment. Doesn't matter what's in there as long as it has enough mass and you're rotating it. So, yeah, I mean, you could put as long as it can handle the speed, the rotational speed of what it's being spun at. You know, you can put anything in there. You know, you can put lead in there, but then you have to be using lead. If you can put iron in, steel, you know, that's, and if you're going to land, you have to then put in steel that unpacks the steel. If not, you can use lead because it's the heaviest thing, or uranium even. You know, maybe you put your uranium in there. You know, and then you know, then suck the uranium out as you go, and you have quite a bit of uranium, but you would need it if you're staying, because you know man, you know, and the other option is to have very gentle acceleration, and take however much time you want to get to Mars or whatever planet you're going to. You know, you do 1G, you can do, you know, 1G, you can't do 1G acceleration and have 1G modules though, that turn into your station. So, yeah. So you'd have to have like if you want to stay perpendicular, it's no acceleration. But that's, you know, again, these are uncollapsed waveforms. Whether we want to spend the money on doing that or whether anybody even wants to listen to this is a question. That's a political question. That is my job as an analyst, a political analyst and philosopher, is to come up with these philosophical questions about the physics, because you have to have the philosophical questions to get the money. I happen to have been a financial specialist, so, you know, and a systems analyst, so I can put the system together and the concepts. I just did. You can map it out. But yeah, but we'll see. Hopefully somebody will see this and, you know, put these two systems together to then come out with a collapsed waveform. Because it's two things, you know, broken washing machine and whether spinning or not is possible for human beings to deal with. So we say the physics is right, but you can't really know until you collapse the waveform and actually build one. And we should build both of them now before we commit to putting much on the moon. And we can do that now and at the same time, you know, and with private money, in fact. You can test both now while going with the original space plan. Just give, you know, if you're rich, you know, send me some money. We'll, you know, and some scientists, and we'll make those tests happen. You know, I can figure out how to configure the thing and the general systems engineering, and, you know, send me money and a crew, and I can get both of them done as fast as you want to pay me. So, yeah. Share this if you want to go to space.